Greetings, my name is Nicara Gordon. I am the IT specialist here at ThinkNChange, and today I will be conducting a technical demo of scale computing. Scale computing is a hyperconverged infrastructure solution that was purpose-built to provide cloud-like simplicity and performance on premises in the data center and all the way out to the edge. A hyperconverged infrastructure is a set of server components consisting of compute, network, and storage. The cloud is a virtualized set of hardware resources that you would access over the internet, such as central processing unit or CPU, random access memory or RAM, storage, and so on. The data center is a specialized area or a place that stores servers such as web servers, database servers, file servers, and so on. These places regulate the appropriate temperature and have security measures in place so that those servers can function the way they're supposed to. The edge refers to wherever your hardware setup is. Scale computing sells the hardware, which you would purchase and install at a location of your choice, whether it is at home or an office. Wherever you install that hardware, that would be the edge, bringing the data closer to where you want to access it. This minimizes any issues that you would face with latency. In addition, with cloud computing, you would have the benefit of accessing the data both from the data center and at the edge, wherever you set up that hardware. That's the benefit of scale computing. Here we have the Fleet Manager on screen. The Fleet Manager is the analysis and monitoring tool that is used to track the health status, the version info, and the current conditions of the different clusters. Now, a cluster has 3 or more nodes or 3 or more servers. If you check the cluster section here, you can see the name of the different clusters, the health, how many nodes or servers that are within those clusters, the virtual machines, the number of virtual machines that are installed in those clusters, the tags that are associated with those clusters, and the amount of resources that are allocated to those clusters, such as storage, memory, CPU, even the version number. The version number is associated with Hypercore. Hypercore is the software that is installed on the scale computing hardware. Hypercore would be the operating system. In the actions over here, it shows that you can go to that particular cluster. The node section shows the type of hardware that you have installed or have established. You have the model of that hardware or node, the serial number of the node, the ship date, the status, whether it's online or offline, the local area network or LAN IP, Internet Protocol, and the cluster that the node belongs to. Here we have the different virtual machines that are listed here. We have the state, the power state, whether it is on or off, the name of the virtual machine, the description, the tags, the IPs, the storage that is allocated to those nodes or clusters. The actions button over to the extreme right shows that you can go into those virtual machines where you see open VM console. What I'm going to do next is that I'm going to show you what a cluster looks like. Over here, this is an example of the user interface of a cluster. The name of this cluster is Pub1. You see Pub1 there as the name of the cluster. Right beside the scale computing brand, you have the version number of that particular cluster, where you have Hypercore established or set up in this particular cluster. Up at the top in the middle here, you have the statistics or the amount of resources that are allocated to this cluster and how many are used. CPU, RAM, storage or disk, IOPS, input output operations per second, which represents how many times the disk is being operated per second. You have LAT, which represents latency. Latency just represents how long it takes for you to send a request to a server and for the server to respond to you. That is typically measured in latency. Here we have 3 blue boxes. These 3 blue boxes are the nodes or the servers. These nodes operate in a very strategic way based on how Scale Computing have set them up. Whenever one of the nodes needs to be upgraded or it is corrupted for any reason, the workload on that particular node would move to the other available nodes until the previous one is finished upgrading or the problem that node is fixed. And then after that operation is completed, then the workload would move back to that specific node. That's how they work together. The blue, vibrant looking bars at the bottom here represents the workloads that are on these particular nodes. Here, this is the button that you can click on to create a virtual machine. You can go ahead and add a name. Add an appropriate name so that in the future you can easily identify it. You can add a description to show what the purpose of that virtual machine is for. You can add tags, your various presets here, or you can type them in manually. These group the virtual machines in a logical format. You can add the operating system. Windows, Linux, and Unix are the ones that are supported by Scale Computing. You can configure the drivers, whether it is performance or compatible. You can configure the boot type. You have the basic input-output system or BIOS. You have the UEFI or the Unified Extensible Firmware Interface. You can even have the Trusted Platform module in addition with the UEFI or TPM or even with compatibility. Now below here are the resources that you can allocate to that specific virtual machine. You can allocate the amount of CPU, memory, drive to that specific virtual machine based on the workloads that you're going to assign to it. And here you have boot from. Boot from contains a little menu with the various ISO files. ISO files are the various installation media that you would use to install various operating systems. These are the operating system installation files. Here in this list you can see various server operating system files. You have Linux based and you have Windows based operating system server files. When you're finished, you can click the create button here. Next, over here you can import your hypercore virtual machine. So when you click here, a little menu will pop up to show that it only supports hypercore format virtual machines only. You would type in your virtual machine name, your SMB server, the username and password, the credentials for that specific virtual machine, the domain and the path for where you want to import that virtual machine from. So you can go ahead and move your workload from a previous setup, such as VMware, over to Scale Computing. These buttons are here where you can expand or collapse the groups. So here, if you click on this, you can collapse all the groups. These groups here were made based on the tags that you've assigned to your specific virtual machines. And you can click on this icon as well to expand all the groups. And they have expanded there. Beside those buttons here, you have show info panel for these virtual machines. You can show the necessary properties for these virtual machines. Here you have the summary of the virtual machine that is shown by default. Next, you can show the devices that are assigned to the virtual machines, These are the different resources, such as the installation media, such as the Windows Server ISO. You have the storage that is assigned to it, and even network, virtual local area network for internet access. And this is the snapshot section for all of the virtual machines, really. Snapshots are used to create backups of these virtual machines. It takes the current state of the operating system and saves it just in case there is any corruption for any reason, and you can restore that snapshot when needed. These snapshots can be used as templates as well to create a separate virtual machine or a different copy of the previous virtual machine. These three menus for the virtual machines, for the different virtual machines, represents the different properties of a virtual machine. The green box here with the power icon goes to show that the virtual machine is powered on, and whenever it doesn't look green and is grayed out, it goes to show that that virtual machine is powered off. This button here, you can click on it. It shows console. When you click on it, you can actually go into that virtual machine. But before I go to a console, if you look at the top right in the cluster, these icons would represent the status of the cluster. It represents different warnings so that you can know the state that your cluster is in. You have all VMs. It goes to show the power status as well, how many virtual machines are running in the cluster, and how many virtual machines are created in the cluster. So you have the total amount of virtual machines in the cluster, and it shows the amount of virtual machines that are currently running in the cluster. In all VMs menu here, you can power on, shut down, power off, or reboot all the virtual machines at once. And here you can create a snapshot, you can clone the virtual machine, or even delete. This menu would be used to perform an action for all the virtual machines at once. Here you can edit your virtual machine with the different settings that you have here. You can move the virtual machine from one node to the next. The grayed out node goes to show that that's the node it is currently on. The other two nodes that are highlighted goes to show that those two nodes are available for the virtual machine to be moved over to. You can delete the virtual machine, you can make a clone of it, or you can create a snapshot. So the buttons on each of these virtual machines are to perform actions on only the current or one virtual machine, while the menu here is to perform these actions for all the virtual machines at once. I'm going to now go into this AIS file virtual machine. Now, this is how it looks when you go into a specific virtual machine. Well, this is just the lock screen of a Windows virtual machine. And here you can look at the setup in this particular virtual machine. What scale computing does is that with this whole hyperconverged infrastructure, they've decided to get rid of the traditional approach or the traditional setup of a server. The traditional setup of a server is where you have the different server components, storage, compute, network from different hardware manufacturers. These manufacturers are different from each other, so whenever you have an issue or when you need support, you would have to contact those different manufacturers, which would take up a lot of time and effort for you, which normally you wouldn't have much time to do that. So scale computing condenses all of these parts in a server so that you can call only scale computing for whatever issue that you're having with your hyperconverged setup. That's the idea of scale computing. This service is offered through ThinkNChange. If you are interested in scale computing, you can contact the following numbers at 1-262-224-6140 or 1-876-287-7984. you can visit our website at ThinkNChange.com or contact us via email with the email address contact.us@thinkandchange.com. So the number that you would call or you would message on WhatsApp is 1-262-224-6140 or 1-876-287-7984. You can visit our website again at thinkandchange.com or email us at contact.us@thinkandchange.com. You would get a representative that will walk you through, or if you have any questions that you want to ask, you can go ahead and send us a message or give us a call with the mediums that I've stated before, because this product is really a product that focuses on making it easier for the IT infrastructure of your business so that you can focus on your work and not having to deal with any headaches with the maintenance of the infrastructure that you would use to make your business operational. Thank you for watching this technical demo, and I hope that this will give you a better understanding of what scale computing is and the service that it offers.